Hello, good morning, good afternoon, good evening, depending on which part of the world you are. Welcome to the SUSECON Digital 22. Today, we are going to discuss a very interesting topic that is disaster recovery for Kubernetes. So, first, just let us introduce ourselves. I'm Suraj Yadav, a business strategist at SUSE, joined by my colleague Deepak Patel. Hey, Deepak, why don't you introduce yourself?
Thank you, Suraj. Hello, everyone. Good morning, good afternoon, good evening. My name is Deepak Patel. I'm a solution architect with the GSI team at SUSE. I'm based out of Bangalore, India. Back to you, Suraj.
Thank you, Deepak. So let me just briefly touch the agenda point. So here we are going to discuss the customer expectation, business continuity plan, a DR readiness, a recovery plan, and execution, and then we'll be concluding it. So let us begin. So Deepak, I'm sure that when you are discussing with your customers and partners about their digital journey, then you must have come across questions and the expectations from the customer. So will you please throw some light on that?
Yeah, sure, Suraj. Yes, in every single conversations with customers, partners, we come across their um, digital transformation initiatives, customers wanting to digitalize their platforms, their services, their applications. One of the reasons is that we are living in an increasingly digital world today. As an example, I don't even now remember when the last I went to a bank in person and physically there, right? The core banking had anyways been digitalized long back, which means that we were able to view and transfer funds electronically. But then also the other financial functions like credit cards, loans, and insurances, and many other functions, they also started digitalizing themselves. And today we are seeing most of it getting digitalized. And we see today banks have gone completely digital, and to some banks which have even gone completely paperless. So all of their functions, right from onboarding the customer, everything is completely through the browser, through their applications, which they can access through computers, through the phones, through the tablets, and whatnot. Similar is the case for e-commerce, right? A couple of years back, we used to walk in grocery stores, do our weekly shopping. Today, we are basically at the comfort of our homes, on our phones, through the software, through the application software. We are placing the grocery orders, making the payments, and the groceries are being delivered to us on our desired times. So things are getting digital, and the customers wants these services now more and more increasingly, 24 by 7 and 365, because they want to do it at their time and at their comforts. This is putting pressure on companies, and companies have slowly and gradually transforming themselves also into what we call software companies. um, the digital transformation is basically fueling also growth for microservices and containers. And Kubernetes is slowly becoming the de facto container management platform, and that's helping containerized applications to be more resilient by nature because of its design. And that's actually increasing the service availability for the customers. So that's correct. The expectation are rising, and so is the organizations gearing up for them as well. But it's important that the customers get these services without interruptions. Now, failures is inevitable. Things will go wrong, right? It could be a hardware failure, it could be a software failure like kernel crash, it could be network issues, it could be cyber attacks, it could be natural calamities like earthquakes, hurricanes, fires, that could all result in really impacting the serviceability of our applications, which means that services being available to our end customers in such eventful situations. So organizations needs to be ready in order to ensure that their services are available to their customers in such situations also. So, Suraj, I want to ask you a question. During your conversations with your customers and partners, what do organizations do to ensure that they keep running even it's in such eventful situations, which is just not in their control?
Of course, Deepak, business interruptions may happen. However, it is imperative for the organizations to have a plan to overcome such eventualities in a minimum possible time, just not the minimum possible time, but also along with a minimum possible data loss. Organizations plan their business continuity model to overcome such unforeseen scenarios, and disaster recovery is one of the aspect of the BCP. So just let me take you to those things in a little bit details. So actually BCP focuses on the planning part, which actually ensures that business critical functions remain operational during and post the disruptive incidents. BCP involves defining any and all kind of risk. So what could be those risks, like your customer's brand reputation? It can be revenue loss. It can be loss of the customer satisfaction. So the customer base can be on at the stake. As a result of an effective business continuity planning, the business can actually better prepare themselves for managing those risks and minimizing that loss which is expected due to this interruptions. So BCP models which they're following that incorporates those framework which makes them a preventive. So at the first step itself, to prepare them to be a preventive, they should have the preparedness. They should have the ability to respond. And at last, if something goes wrong, then they should have the recovery planning to overcome that situation. A disaster recovery plan is actually a formal document which organizations build, and that contains details of the instructions, the team, the collaboration between the different stakeholders, how to respond during unplanned situations and the incidents. For example, if there is a power outage or a cyber attack or any disruptive events. So BCP and DR in total makes the business and organization ready for any unforeseen situations. Deepak.
Yeah, I just learned the PPPR model, which is the preparedness, preventiveness, sorry, preparedness, responsiveness, and the recovery. So yeah, that's a good learning. Can you explain the recovery plan as to in order if someone has to build it from scratch, right? What would they think about in and what would they have to have as a part of the plan so that it is impactful for them and it rescues them during such events.
Yeah, that's a right question, Deepak. So before going into the details of the DR plan, first and foremost thing is that we have to understand that what should be the characteristics of the DR readiness. So the plan should be simple enough to be understood by our various stakeholders, whether those are technical, non-technical. They can understand the plan and they can act accordingly. Whenever we are executing that plan one time or several times, doesn't matter, our outcome should always be consistent. And whenever we are executing a plan, definitely there are some findings which we have to incorporate. There are lessons learned. So the plan should be adaptable. We should incorporate those changes and then make a plan and then test it and then execute it. However, the plan should have a huge number of checklists, and we cannot cover everything here, but some of those which are important I would like to highlight here. So first thing is that you should understand, you should analyze your business, you should understand the impact of the business, you should have an understanding of the risk involved with that one. You must need to know that which are your mission critical business units, which are your business critical units, and which are just normal functions, which are actually an enablement for other operations. Yes, exactly, Deepak. We should have a exact definition of the recovery objectives aligned to those business units, and just not the business units, but which all underlying systems are enabling those business unit to perform and operate. Because if those systems are not there, then definitely it is very hard for those business units to perform. We should have disaster recovery sites available. We have a plan, we have a preparedness to fail back. We have the right people, the right team, assign the right roles. They must aware about their responsibilities. We have to have a common repository in case of disaster event. Those repositories, those documents can be accessed, can be understood clearly. We have the necessary tooling and the equipments in place. We have the right channel to communicate. We should have detailed disaster recovery and the response procedures in place. We have the right stakeholders to respond in the incident. We must need to test our plan rigorously multiple times. And last but not least, we should have the right disaster recovery strategy in place.
Sounds good. Sounds good. So, if I kind of summarize, the DR plan is essentially a subset of BCP. The DR plan is actually a living document, which should have three basic elements. To keep it simple, it should be simple enough to understand what is the plan about, who's the stakeholders, right, and all that. It needs to be adaptable, uh, which means that when we implement it, and if you observe that there is gaps, it should be changed enough that we could adapt them, and then it should be repeatable, so that for that particular event, and for that particular applications, that particular DR plan can be implemented in a repeated manner, to ensure that there is no un, there's no surprises, essentially. Yeah, no, good point. Can you cover for me, the most important thing is, the risk, right? So, can you cover the risk assessment and also the business impact analysis that you would want to be doing as a customer or as a partner for your customer?
Yeah, that's the right question to ask, Deepak. So let us understand the risk analysis and the recovery objectives around that. So when we talk about the risk analysis, it means we have the clear-cut demarcation of the business functions and the underlying assets. So, for example, if there is a services being offered, so on which systems those services are being offered, how is the landscape defined for those systems, and when we talk about those systems, then how fast they should be recovered, how much data they are carrying. So all those things, those aspects should come under the risk and business impact analysis. And another aspect which is most important to understand is the recovery objective. And when we talk about the recovery objectives, so those recovery objectives are recovery point objectives and recovery time objectives. In the simple terms, recovery point objectives or RPO means how much appetite I have to lose the data. And when I talk about the recovery time objectives, the RTO is that how fast I can come back to the business. So let me explain with a one simple example that in an event of the disaster, uh, I may lose a data for 15 minutes, and that's okay because I know that that data can be either rebuilt or it is not necessary for me to start my business on that data. Similarly, I can come back to the business within 30 minutes or say 1 hour to 4 hours. So those the data loss appetite is RPO and how fast I come back in half an hour to 4 hour, or for some business units it might be a couple of hours to days. That is called the RTO.
So, it does it really depend on the industry vertical and the solutions that you are using, and RTO typically would be aligned to them.
Yes, for example, the healthcare industry and the financial industry. So those are some of the examples where very stringent RTO RPOs are being defined. So definitely the industry vertical, and within that one, what functions you are talking about, and means considering those are really make relevance, Deepak.
Great. Any statistics that you want to share to the audience today?
Yes, Deepak, it's a right query here. So 451 Research Analysis has published some data. So just let me briefly touch base on that part. So they have actually they have done a very beautiful categorization of the system, like a mission critical system, business critical, and the non-critical. There they have tried to portray that one, how important it is to define that landscape in that category, that 19% of the mission critical requires a less than 1 minute of the RPO, while only the 9% and the 2% systems are required RPO of 1 minute. And why is it that important? Because in the last column, if you see that as the cost impact, you have the stringent RTO and RPO, higher the cost is. Why you want to put all of your money in managing a very stringent RTO RPO when you know that those you can live without those functionalities or those application for a couple of minutes to couple of hours, or in that matter for few days. So it is really right strategy and an important aspect to understand the risk associated with your business functions and the applications associated. Similarly, let me take you to the RTO figures. So here, 11% mission critical systems required an RTO of less than 1 minute, means those systems should be available within a minute, while just 4% and then 1% business critical and non-critical systems are required RTO of less than 1 minute. In contrast to this one, if you see this one, 53% of the non-critical systems and just 8% and 5% of the mission critical systems require 20, more than 24 hours of the RTO. So it is really wise to analyze your risk assessment and accordingly plan the recovery objectives.
So, I mean, when you categorize the system, if I may give an example, right, and you can validate if my understanding is correct. Let's say, for example, e-commerce, right, where your applications consist of microservices, and there are various microservices, that works together to really give an application experience, the full blown experience to the customer. Typically, the payment, is the last one, right, and that's the core, that's the most mission critical piece for them, along with, of course, other microservices as well, right? But I mean, typically, if you see the flow, if we select the products, but then if the transaction doesn't go through, yeah, then you'll need to repeat that steps again, or hopefully they have their own microservices logic which will store all your items in their carts, and then you can, of course, retry and check out. But every microservices or some, depending on the design, will have the last one, which is finance, and then if it doesn't go through, then that becomes your mission critical. But for that same company, right, if they are doing continuous integrations, and Jenkins becomes a classic example where it becomes a business critical versus a mission critical, because it's supporting the application. And if Jenkins is not available for a couple of hours, for some reason, the only thing that may not excuse me that may not get done is the incremental changes, the small incremental changes that they're looking for to adapt. And that's the only thing, but it's not taking away the entire business off, right? So would that be an accurate understanding of the business and of the mission and the business critical?
Exactly, Deepak, you have nailed it.
Okay.
Uh, that's the exact example. Yeah.
Perfect, perfect, and glad to know that these numbers give our audience a good perspective as to uh, every applications, right, will need to have their own RTO RPO depending on the scope of the impact that it can have to the business, right? So if it's the most mission critical one, you need to shell out more money. And if it's a non-critical one, then you may spend an decent amount of money, but may not have to overshell to keep those systems available. Now, great point of view. So thank you so much.
Deepak, let me ask you this question. Uh, we understood the risk assessment, we have defined the right RTO, RPO. So, can you bring some light on that part? Means how the underlying infrastructure is actually analyzed in a way that the right RTO and RPO is being assigned to those systems and applications?
Sure. Yeah. And so, we all know workloads, right? And when we talk particularly about the containerized workloads, they are just distributed in nature, right? So they may not just reside in, or you may choose the workload to be the way that you can design it the way that you want, and then it's distributed. It could be running, part of your workload could be running on your own data center or your own private cloud, and a part of that same workload for the application could be running on public cloud, and also could be running on your let's say retail stores at the edge, or the application may be running on a 5G tower somewhere at the at the remote edge of the network, right? So these are various landscapes that our containerized applications would run, and we really need to understand these various landscapes and what really helps our applications, microservice applications, to be available. Along with these landscapes, we also need to understand the underlying infrastructure which helps us to keep the workload running, which is storage, right? We could have a dedicated SAN to ensure that there is a high throughput available for our applications. But think about it, you can have a SAN on a remote edge, right? So you need to have storage for such applications close to where they are processed, right? So we need to understand those constraints, and there is other things which gets to make up the workload, which we typically ignore, is the networking components and even the security components, right? So all of these things build up our application, and it depends on from what view you're looking at. But if you're a developer, you just write codes. But for infra guys, these are really important things that they need to really factor in. And and since we're talking about microservices and containers, right? Kubernetes is basically the de facto standard for running microservice, de facto container management platform, and it's helping us to really abstract the underlying hardware and give us a common compute platform where we can run our applications. So in cases of Kubernetes, we may call it like a single cluster, multi-cluster, or it could be running on one cluster could be running on your data center. The other cluster where you need those computes could be running somewhere on the edge, right? So Kubernetes is helping us to kind of abstract a lot of underlining hardwares that we are using, and abstracting and giving us the ability to run our containerized workload. So I think those are some important things that we need to understand for our workloads. We need to really consider that. And then when we're really talking about Kubernetes or containerized workloads, right? Then we are really talking about Kubernetes in essentials, right? So in Kubernetes, we really need to understand what do we really need to backup, right? Because it's important that if you don't have backups, right, we won't be able to restore those applications when the event arises where we have to restore services, right? So what what do we need to understand when we look at Kubernetes is the first and the very important thing is Kubernetes is resilient in the way that it is a distributed architecture and helps us to be resilient, but it's not really prone to disaster that we have already covered in the previous slides. But in addition to that, it really doesn't have a native tool for your DR, right? So we really need to invest in backup solutions. What are the components that we think that we need to really have backup of, right? Because when we are talking about Kubernetes, we are just not talking about one single cluster. We are talking about the container management platform, and then we are talking about each and every individual clusters, which is a complete unit, self-containing unit in itself. So we really need to back up the very essential heart of Kubernetes is the HCD database. And we really need to back up our HCD database for the cluster. And from a container management platform perspective, again, for example, let's say Rancher, right? So Rancher is a microservices applications and runs on a container. And if we back up HCD for that particular cluster, we're going to be backing up the Kubernetes objects. But remember, we have the Rancher as an application, so we also need the appropriate schema for Rancher for that particular application for whatever the objects that it's building, so that it needs to have its own backup operators, and Rancher does provide you with its backup operator where you can really back up your container management platform. So we're looking at securing our container management platform in first place. Then we are looking at every single individual clusters that we really need to back up, and HCD is the first thing and the most important thing we need to back up. But in addition to that, there's also other things that we would need to factor in is the namespaces, because the applications will run in its particular namespaces. So we really need to back up our namespaces. In addition to namespaces, we also need to back up the construct of the application that we are having, right? Typically the YAML files, right? You may have one single common YAML file, and you could break the YAML files with three dots, with three separators, right? With a three hash. And then we can build up one single file, or you will have multiple YAML files which will constitute your application. So typically we need to back those up as well. In addition to that, we also need to back up certificates, because certificates provide us a secure connectivity between the applications, right? So we really need to also back the certificates up. We also need to back up any custom role-based access controls that we have had for our cluster, so that those can be available when we rebuild them. Because look, if you don't, then we're not going to get access to those objects later. So and I just wanted to add two more things. We also need to add the container images, because container images is what we build our application with, right? So if we don't get the container images, look, you're not going to get the applications. So we may choose to have private registry or a public registry, or some registry where we are storing these images. We need to really secure them up as well. And finally, we all know, in Kubernetes, your applications are either stateful or stateless. Stateful's anyways taken care when you backing up your HCD, but with stateful applications, you are creating data which is not stored in HCD. It needs to be stored on persistent volume so that it can be accessed later by the application. So we really need to back up persistent volume as well. These are a few. It's not a it's not a comprehensive list, but this is some of the important things that I thought that I should cover as a part of the readiness. Because If we do not have these, right, we can't really recover from disaster if we need to restore our applications. So, Suraj.
That's a wonderful explanation, Deepak. So, in a nutshell, what I understood that being a Kubernetes, although it's a highly resilient, but there is nothing out of box for the disaster recovery. So we must need to be prepared. And as we know that Kubernetes has itself some of the stateful and the stateless components. So definitely for the stateless components, we don't need them to be really backed up, but for the faster accessibility and quick response, we need to be better prepared with those things. So that's a wonderful explanation, Deepak. So will you please describe some of the tools which are available there for the back?
Oh yeah, yeah. Oh yeah, yeah, yeah. Sorry, I wanted to be agnostic, so but to name a few, right? I mean, you could lean on vendors like Portworx, Veeam, Velero, which will help you with backing up your not just your application data, but also part of the cluster data that you would need to, in addition to the regular CSI backups that you can, of course, do with the out of the box Kubernetes solution. But then, if you need to really have a fine grained control on what you need to back up, and things to be really easily consumed, I think investing in a proper backup solution would be of great help during the recovery process, or during the restore process, I would say.
So, Deepak, when we talk about the rancher, so for example, if we have to download and then install these kind of tools, so do you think that is there any a common place within the rancher itself where we can have access to these tools?
Yeah, so Rancher provides us with what we call application catalog, or a Rancher catalog, and all the Helm-based applications which are packaged. They are readily available at one single place, and with just a few clicks, off you go. These applications can be deployed on any of the downstream cluster that Rancher manages. So that's one. And then, in addition to it, if you need to, if your application vendor, if you want to build your own hem charts and your own catalog, you can also do that through Rancher. Rancher allows you to create those as well. So both out of the box solution available is there. We have certified partners, so those hem charts are readily available in one central place. It's just a few clicks and off you go. But then, if you need something to have your own custom ones, where you want to have it published as a part of your as a part of your organization, or as a part of the services that you provide, that can be also done through Rancher as well. Does that answer the question?
Yeah, thank you very much, Deepak. It's
Hmm.
absolutely good to know that.
Perfect, perfect. So, hey, Suraj, let me ask you. Yeah, we have so far we have covered what we really need to back up. We have identified them. We know what are the components in Kubernetes, and what are the other things in terms of the infra that we need to really have availability for, right? So that these are available when required. We know the Kubernetes components that we need to back up. But in terms of the recovery, when actually there is an eventful situation, could you highlight the recovery plans that should be part of what we discussed during the DR strategy, or part of the DR document, right? The important one, the recovery. So if you can throw some light on it, that would be great.
Yeah, Deepak, it's as critical as the other components what we have talked about. So just let me quickly tell you that. So in general, we have these three strategies which we generally see. That is the failover, a rebuild, and the restore. So failover means we have identical set of the clusters running where our production workload can be shifted during the disaster event. It can be done in a various ways, so I'll just discuss in detail. Rebuild, which is based on the GetOps, which is where you can put your infrastructure as a code and those automation scripts directly available. You can directly build your environment right from the scratch. And third one is the restore. In certain scenarios, definitely we need to restore from the existing backups and the snapshot. So that is applicable. So it is not like that just one strategy is applicable to one particular situation, but within the business organizations, there are multiple applications running, there are multiple sites running. So it's a combination of the strategies for which business unit, for which applications, which is the best strategy. So just let me little bit inside of each. So when we talk about the failover scenario, so the failover scenario, generally what happens that when we have workloads running in a production environment, so there is a high availability. And when we talk about the high availability, means there are two identical set of infrastructure, piece of infrastructure on which the workloads are running. So those identical infrastructure environments can be within the same data center or in a couple of miles apart, they are be running, so that whenever there is a disaster event or any wrongful situation happening, so itself we are preventing ourselves from going into the disaster. Then at first place, I don't need to go for the recovery or anything. So our infrastructure should be resilient enough to handle that interruptions. And in unforced scenario, if it is something goes wrong, then we have an arrangement of identical site, which is again can be a couple of miles away from the existing data center or altogether be running in a different region itself. So the availability of this site can be in an active mode or it can be in a passive mode. When we say in an active mode, it means every piece of infrastructure and applications, those things are already in place, everything is running. Just in case of disaster, we just have to switch the network from here to there, and you are back to the business. In contrast to the passive sites, what happens that we have those arrangements ready. There is a certain interval on which the data being copied, and some of the infrastructure piece is to be prepared when we are done with the disaster recovery, disaster situation, and we have to go into the recovery mode. So these models are also known as a hot site and the cold sites. So let me move to the GitOps. So this, when we talk about the Kubernetes, so it is one of the most loved strategies because its nature and its availability of the GitOps, and Kubernetes provides us a common compute platform to utilize GitOps in a very efficient manner. We have all those tools available, Terraform, Chef, Puppet. Using those tools, we can build the underlying infrastructure in a couple of minutes. And on top of that, we can just build the Kubernetes cluster. Once the Kubernetes cluster is available, then definitely we need to arrange for all those required applications which supports your cluster, mainly known as the cluster tooling. And once everything is set up on top of this one, we can just deploy our workload, and we are back to the business to run this one. So Rancher, Deepak, has a built-in tool which called the fleet, which is actually GitOps at the scale, and it provides delivery. Yes, exactly, and it's provides a facility to manage up to the million clusters directly there.
Oh wow. Oh, that's a huge number.
Yes,
I think that's something really big,
yeah.
which even highlights the power of Rancher container management platform, that it can support up to million clusters. Wow, that's big.
Yeah, and Rancher has out of the box cluster tools. So, for example, if you have to build any monitoring observability thing, you just go to the cluster tools and you can just start installing it. And as you said that it has a wide variety of applications and its marketplace where we can directly go and within a click we can install those applications and we are just ready. The best part of the GitOps is that it is just not one cluster. If you if you if you build one cluster in a few seconds, the exactly same time it will require to replicate the number of clusters, right? So it gives you the flexibility and the scale at which you have to really manage the massive scale of the infrastructure and the applications and nowadays in a digital scenario. So let me take you to the
So, so the previous slide, if you don't mind,
yeah.
that's the rebuild uh, pattern of recovery using GitOps. Okay,
Yes,
fair enough.
exactly, Deepak. Yeah. So let me come to the backup part. So there are certain scenarios where we cannot eliminate that. Uh, we have to restore from the existing data. So we have to understand that which are the applications and the components within the applications where we need to keep the backup, the base images. We have to keep building the journal of the data changes in terms of the snapshots that has to be placed on a secure location that when eventualities happens, then we can restore directly from those backups. So there are all different strategies, and as and when it is required within the business units or across the business units, the right and appropriate strategy or the combination of these strategies can be implemented. Deepak.
Oh, that's good. So if I have to summarize, what we have covered so far, basically from the recovery perspective at a high level, you can have a failover as a strategy. The second strategy is to rebuild the cluster because you don't want to invest time in troubleshooting the issue. What's really gone wrong because of automation. You can really deploy these clusters within just no time and get up and working with fleet where your applications also gets up and running in really no time. And you can do this for a lot of clusters or for a lot of sites based on what your requirement is. And the final one is the recovery plan, where let's say you need to really uh, get to restore it from your backups, which was the last successful backup that you have, or basically the snapshots. You can restore snapshots as well. So no, great information. If I have to put it this way, right? If we look, if we summarize everything that what we have learned, and I know the last part is the execution, so that's a critical one. So you basically plan your DR plan, you ensure that you have the right DR plan. You know your landscapes, you know what applications RTO RPOs are. You do the backups of the required components, when I say components, I'm saying Kubernetes and the applications
Yeah.
and the data. You keep that secure, so that when we really need to execute it during the event of disaster, we can use them. So the idea is to plan, is to do a dry run. That's the most
Yeah.
important, because you may have a thought process in your mind when you're building the plan, but it needs to be validated to ensure that what your thought process is and the outcomes are, they're getting aligned. And if they're not, then basically we need to look for the gaps, and then make sure that we rerun and fix those gaps, and then reach to the desired outcomes, so that the DR plan becomes adaptable and can be consumed, and can be repeated over times. So which means that we need to plan, we need to do dry run, we need to analyze, and we need to adapt. And that's basically the circle that we need to take, so that it becomes always a living document. Brilliant. So if I have to summarize this, real quick, right? What we covered is what's the customer's expectations, right? They want services to be available 365 days, 24 by 7, 365 days a year. Organizations needs to have plan and strategies in place to do that. In terms of disaster recovery, you also needs to be operational. So for that, you have a disaster recovery plan. You outline the plan. You build up the plan in such a way that you know what you need to back up, and then what plan to use, what disaster recovery you need to use for which application, because not all applications will be using the same recovery plannings, right? And you execute them, you know gaps, you fill them, and that's how you kind of have this living document which keeps you running all the time. I hope that summarizes things accurately, Suraj.
Exactly, exactly, Deepak. You have exactly
Thank you.
summarized that.
Thank you. And look, really, super explanation, Suraj. Thank you. It was fantastic. We went through this topic, and I'm hope if there is questions audience has, they know how to reach out to
Yes,
us, right?
they can reach
They
out
have
to our
they,
emails and the phone numbers mentioned in the initials of the deck.
Exactly. So, thank you, audience. We really appreciate your time. And then, if you have questions, come back to us. Till then, bye from Deepak and Suraj from SUSE. Thank you so much.
Thank you
Bye
very
for now.
much for being with us in SUSECON Digital 22.